Is going to be about creating line graphs to display data that we have from whatever that we collected data from. In this particular one, we're going to use the problem with this data table here, Ryan's height. You can see that his age in years, 1 through 5, and then it looks like he measured every day on maybe his birthday in inches. So when we make a graph, there's a few things that we have to have before we start. Okay, the first thing is a title. You'll see here that Ryan's height is the same name as the data here, so we put Ryan's height at the top. You need to have an X and a Y axis. So the X is horizontal, the Y is vertical, and we always have an arrow at the end to show that it goes on and on and on. An X and Y axis label, so we have to show what each axis is representing in our data. And when you do line graphs, one of the most important things to remember is that the one that deals with time, which would be in this case years, the one that deals with time always goes on the x-axis. So you can see they put age in years down here because that deals with time. The other label then would be your other data, so the height in inches, that would go on the y-axis. Okay, then you want to have a good scale. Scale are the numbers here. So if we look at the age in years, we can see that the most Ryan has here on his data table is 5. So we want to make sure that 5 fits in down here. So obviously on this one we would count by ones, so that's your interval. We're going to have an interval of 1 so we can get to 5. Now the height's a different story because this one goes all the way up to 44. Okay, so we need to have our data go clear up to 44 on our graph. So in this case it would make sense to count by, they're actually counting by 5s, but they're only labeling every other one at 10. Okay, so we can get all the way up here to 44. Okay, so those are the things that you have to have in order to set up a graph. Your title, your X and Y axis, your X and Y axis labels, and you have to have good scales with a good interval. Okay, so after we do that, then we take our data and we're going to create ordered pairs like we've been working on. So the first one on our X, so when he was 1 year old, how tall was he on his Y? Well, it looks like 30. So the first point would be 1 comma 30. The second point would be when he was 2, he was 35 inches. So it would be 2 comma 35. The third one would be, 38 inches, so 3 comma 38. The fourth one was 41 inches, 4 comma 41. And the fifth year was 44 inches. Okay? Alright, so after we've done that, now we can start putting the points on our graph. Okay, so we'll plot this one here, and I'll get something here to help us with this. It's a little big. Okay, so we'll plot the first point, 1 comma 30, or when he was 1 year old, he was 30 inches. So we'll plot our point there. When he was 2 years old, or the second ordered pair, he was 35. Okay, now we don't have a 35, but we know it's right between 30 and 40. When he was 3 years old, he was 38. Well, that's going to be between 35 and 40, so it's probably going to be more like right there. When he was 4 years old, he was 41, so that's just a little bit over 40. When he was 5 years old, he was 44, which means it's pretty close to 45. Okay, so after you plot your points, then you want to take a straight edge and you want to, connect these together. All right, so I'm going to get my straight edge here so I can do this. So from there to there, from there to there. Computer's kind of jumpy here. There to there, there to there. Okay, so it creates a line, and that one's awful, so yours should go right between the points. And we can kind of see what's happening here. So if the line graph is increasing, in this case, Ryan would be growing. If it's going the other way, going down, that would mean he's shrinking. And if it's straight across, that means he's not growing at all. So in this case, it looks like he's growing, which most people up until they're 5 years old do. Now, something else we can talk about here is, like, for example, between what 2 years did he grow the most? Well, there's two ways you can do that. You could subtract these. You can see you grew 5 there, 3 there, 3 there, and 3 there. So he grew the most between 1 and 2 years old. Or you can look on your graph and find the steepest part of your graph. The steepest part means it's going to increase the most. Okay? The other ones looks like they all increase the same. Now something else that we can kind of do, even though we don't know for sure, is we can have a good educated guess of how tall he would be when he was 6. Well, if I know we're growing 5 inches here, 3 inches here, 3 inches here, and 3 inches here, it'd be reasonable to guess that he might grow another 3 inches when he's 6 years old, which would put him at 47 inches. Okay, so if you look at the line though, you can kind of see that the line's following the same path through that point. Okay, so that's how we can make like a reasonable guess of where he'd be when he's 6 or 7. Now eventually he's going to stop growing, so this graph is going to climb and then it's going to start leveling out. Okay, so that's the lesson that we learned on line graphs.